welcome to the deep dive.
So today we're digging into something really fundamental, the photoelectric effect. But we're looking at it through a totally different lens.
Yeah, based on some, really interesting material you, our listener, sent over, it outlines this alternative idea called motion theory.
Exactly. And our mission today is to, unpack this motion theory, see what it might mean for how we think about light, maybe even quantum mechanics itself.
It's a big topic. I mean, the standard story is Einstein's, right? Nobel Prize and everything. Light comes in little packets, photons.
Well, it's discrete bits of energy. They hit a metal surface.
And if the photon's frequency is high enough, pop, an electron gets ejected. It's foundational stuff.
Absolutely foundational. But these sources we're looking at, they ask a pretty radical question. What if we've fundamentally misinterpreted what's even happening at the detector?
That's the crux of it, yeah. Motion theory flips the script. It says light isn't particles, not photons. Instead, it's structured rhythmic motion. Think waves, maybe complex loops of motion. Okay, structured motion, loops, and the detector, the metal surface.
Not just a passive target waiting to be hit. It's described as a grid of nested loops. Basically, electrons already existing within these atomic sort of sync systems.
Sync systems. Okay, so hold on. If there are no photons hitting things, how does an electron actually get ejected? Where does the energy come from?
See, it shifts from energy transfer to something else. Motion alignment collapse. Or you could call it getting desynced.
Desynced.
Yeah. The idea is when the incoming light's rhythm, its frequency hits a specific point, it disrupts the electron's own inherent rhythm, its stability within that atomic sync system.
So it's not knocked out by force.
Exactly. It exits because its internal synchronicity, its stability, is broken by this external rhythmic pattern. The sync fails.
Oh, wow. A really different mechanism.
Hi.
Okay, so then why doesn't low-frequency light work, even if it's really intense, bright light?
In this model, it's because the rhythm is just too slow. It doesn't have the right tempo, if you will, to reach the electron loop's sync resonance threshold.
Like pushing a swing at the wrong time.
Kind of, yeah. You need that precise frequency, that correct timing to disrupt the electron's sync. Slow rhythms just don't cut it.
Okay. And what about the fact that electron ejection seems instantaneous once you do hit that frequency threshold? The standard model explains that well.
Motion theory explains it too, but differently. It sees sync alignment as binary. It's either synced or it's not, locked in or broken.
So there's no gradual energy buildup.
Precisely. The moment the incoming motion's frequency hits that critical threshold, the electron's sync breaks. Instantly. It's a threshold event, not an accumulation one.
The source material uses this phrase, the detector fooled everyone.
I was thinking there.
Well, it's about perspective, isn't it? Legacy science, as it's put, saw detection as a thing arriving, a photon-particle landing.
Right. Click. Photon detected.
But motion theory argues it's actually a resonance resolution event. The detector itself, with its own inherent rhythmic structure, is actively responding when an external pattern of motion crosses a critical sync boundary. The detector isn't passive. So, the really provocative takeaway here is maybe photons as actual physical particles don't exist.
That's the implication, yeah. It's radical. What we measure and call photons could be misinterpretations of these moments, these thresholded sync points, the behavior of these fundamental motion loops reaching a critical resonance.
So the quantum jumps we see are really these discrete sync thresholds being crossed.
That's the proposal. Quantum behavior arising from resonance and sync, not little bullets of energy.
Okay, let's try to wrap our heads around the core claims of motion theory then. Photoelectric effect shows detectors are motion sync systems.
Right. Light is structured rhythm, not particles.
And frequency is all about timing alignment, which can break the sync rather than delivering a packet of energy.
You got it. That's the essence. It doesn't necessarily throw out Einstein's observations, but it offers a completely different underlying mechanism. Maybe, as the source suggests, it's like finishing the loop on that understanding.
A potential evolution of the idea. So the big paradigm shift is from thinking about energy transfer via particles
to thinking about resonance, timing, and the synchronization of motion as the fundamental processes.
Okay, so here's a final thought then for you listening. If something as established as the photoelectric effect could potentially be explained by motion and rhythm, instead of particles and energy, well, what else in physics might be open to that kind of reinterpretation?
It makes you wonder, doesn't it? What if the universe, at its deepest level, operates more on principles of synchronicity and structured motion than we currently assume?
Definitely something to think about.
Yeah.
This has been a fascinating glimpse into how questioning fundamental assumptions can really open up new ways of seeing things.